Thank you for joining me for this video. I am Mr. Rich. Movement of an object. I have this certain set of equations here which describes a movement of an object. A certain restraint on that movement. X is equal to 2 sine theta, y is equal to 4 plus cosine theta. Theta has a value greater than or equal to 0 and less than or equal to 3 pi over 2. We have to analyze the movement of this object. What are you thinking about in your head? If I'm looking at this and I'm looking at this, I have x, y, and I have a third variable theta. I'm thinking about a parameter. The theta here is a parameter. Therefore, I have two parametric equations. We have to analyze them. The analysis will give us the movement of the object. When I'm looking at this, I have x over 2 is equal to sine theta. Originally, we have x is equal to 2 sine theta and we have y is equal to 4 plus cosine theta. When I'm looking at that, I bring the 4 on the other side. Y minus 4 is equal to cosine theta. I square everything over here. What I squared? Because I'm seeing sines and cosines, and when I square them, I get this identity: sine square plus cosine square is equal to 1, theta or x. You know that trigonometric identity. When I square everything, it helps me eliminate the parameter here being theta. I have an x squared over 4 is equal to sine squared theta. Here I have y minus 4 whole square over 1. Let's just bring a 1 is equal to cosine squared theta. In all instances, these two are equal to 1. Therefore, what they represent should also equal to 1 in terms of a adding relationship. I'll have an x squared over 4 plus y minus 4 whole square over 1 is equal to 1. Because the identity is equal to 1. Sine squared cosine squared equals 1. Therefore, what they represent should also add and equal to 1. What does this look like to you? Well, if you say it represents some form of a curved path, you are right. You're on the correct path. But if you say it looks something more like an ellipse or an elliptical path, then you're even better. Because this looks like an ellipse of the form you know, x squared over a squared plus y squared over b squared is equal to 1. That's exactly what I have. Here my a squared is a 4, therefore a is equal to 2. B squared is a 1, therefore b is equal to 1. You don't need to know the c value, the focal point. You know, when you look here in the numerator, you have something here with regards to a translation, but the translation here is with regards to the y, and it's not too hard to analyze it. The center is not about the origin, but the center here is 0, 4. When you analyze it, you have 1, 2, 3, 4. Here's my center, but you have a major axis, the transverse major axis, 2 on each side. So you know you're gonna go 2 on each side. You'll have one vertex here, one vertex here. This vertex point will be 2, 4. This here will be minus 2, 4. You have a minor axis which is just 1 unit above and below, because this is a horizontally oriented ellipse. An ellipse which has a major axis along the horizontal dimension. You have a minor axis point here, 1 here. And your minor axis points are going to be 0, 5 and 0, 3. And it's not too hard. That right there represents your ellipse. But this constraint right here will represent the movement. We have everything over here. How do we determine the movement? Well, it's not hard. What I can do is represent the equation over here, so I can create space for you over there. My equation was x squared over 4. You have a 1 over here, and then you have a 4 over here. And that right there is my equation, which has been generated by eliminating the parameter theta. The analysis of the theta or the parameter from small to large will give you the direction of your movement and the amount of your movement. You have something here, a theta, you have an x, you have a y. I have a domain here, 0 to 3 pi over 2, and what are my values? I can do by pi over 2, 0 pi over 2, pi, and 3 pi over 2. And how do I know where I put these values in? 0 pi over 2, pi, 3 pi over 2. I put them in these equations, or these original equations right here. When theta is a 0, you put everything in here, you get a 0 in terms of the x. When theta is a 0, you put everything right here. You have a 4 plus cosine of 0, which is a 1, you get a 5. 0, 5 represents right here. This represents here my start. The particle or the movement of the object will start here from 0, 5. And then when I put the next value, because it's always in the increasing direction of the parameter values. Here we're increasing the parameter, therefore the orientation of your curve will be based on what happens from the increasing values of your parameter. When I put pi over 2 here, I get 2 sine of pi over 2, I get a 2. When I put pi over 2 here, that's a 0, but I get a 4. 2, 4. Well, that represents my next spot, my next point where the object ends up. Then I put pi. Sine of pi is a 0. Well, pi here is a minus 1 plus 4 is a 3. 0, 3, I end up right over here. at the minor axis endpoint, then 3 pi over 2, I get a minus 2 over here. 3 pi over 2 is a 0, but I get a 4 over here. Minus 2 comma 4, I end up right over here. So that tells you you end right here. You start from right here, you move in this direction. What is this direction? It's clockwise. You're moving in a clockwise direction in an ellipsoidal manner, or in an elliptical manner. I guess ellipsoidal will be a better term. In an ellipse manner, you're moving in a clockwise direction. Your exact movement is from right here, you're ending up here at the major axis, then you're ending up here at one of the minor axes, and then you end up here at the other major axis. You start from a minor axis endpoint, you go to one of your vertices, and you end up at your other minor axis endpoint, then you terminate here at your final point being your other vertex. And that's my start, that's my end. Movement is in this direction, and that's where the object starts. And that movement is clearly represented by these two parametric equations and by the constraint of your parameter, which right now brings us to the end of this video. This is not a difficult question, but it's an important type of question because you can easily represent the movement of an object by means of parametric equations. Thank you for watching. Have a good day.